All right, so we're going to write, solve, and graph an inequality that involves the distributive property based off of this word problem. As with every word problem, as is the same pattern that we've been doing a lot, you've got to look at what the important information is within the problem. So our first piece of important information is the 25 scholar recipients that this dinner is going to have. So we also know that each winner is allowed to bring 2 guests to the dinner. This also has a piece of assumed information that a lot of times we have problems that are assuming that you're going to kind of make a connection without explicitly telling you anything. So the assumption here, this is a dinner. So if each of the 25 recipients gets to bring 2 guests, each person is actually there's going to be 3 people involved with each person, because that's the person that's getting the scholarship and the 2 people who they're bringing. So 3 people are going to have a dinner at this awards banquet. We also know that each scholarship is worth $1,000. So for each person getting a scholarship, the nonprofit has to give them that $1,000 of scholarship. So that's something else to pay attention to. So for every recipient, there's 3 people eating and $1,000. So that, to me, is what tells me that this is going to be a distributive property model, because we're able to multiply to more than one thing. We also know that the nonprofit pays out $3,575 for the venue. So that, to me, is a constant. That's not something that's going to change no matter how many people that are coming to this dinner. $3,575 pays for the venue. Our question here is, what is the maximum cost per plate that the nonprofit can afford if they're keeping that awards banquet budget to $31,575 or less? So setting a budget, creating a budget, and following it, those are things that are likely to happen in your real life. So this is a situation that could come up, especially if you end up working in a capacity where you are actually creating these budgets for your company to stick to. So if we're writing out what we know, that X, that variable, the unknown is that cost per plate, and we know it's a maximum, so it's not going over this cost. So we're trying to stick to this budget. We have a max cost, and we can go below it. We know that there are 25 scholarship recipients. That is a coefficient, because we know we're multiplying the number of scholarship recipients by something, by the number of dinners, by the number of scholarships being given out, or the amount of the scholarship. We know that each recipient and 2 guests gives 3 people attending for each scholarship given. That looks like a coefficient too. This is another clue that I'm working with distributive property when I have multiple coefficients, and no indication of multiple variables showing up. We know that $1,000 is the value of the scholarship. That looks to be a type of constant as well, because that's not going to change. The value of the scholarship is $1,000. We're just going to have 25 of those given out. That $3,575 is a venue, also a constant. And $31,575 is the total budget ceiling. So that lets me know that that's going to be the thing that's kind of by itself on one side of our inequalities. So when we're writing this out, I know that there are 25 scholarship recipients. I know that for each scholarship recipient, 3 people are eating. So that's a plate. That's our unknown. We don't know how much the plate costs. All this ends up helping to go into our budget calculation. We also know that each scholarship recipient, the nonprofit owes them $1,000. So that 25 multiplies by the 3 plates and the $1,000 to help us figure out our budget. And in addition to this cost, there's a $3,575 cost for the venue, one-time payment, and all this needs to be less than or equal to our target budget of $31,575. So now we can go through and solve it. So talked about this before. Distribution, couple ways to do it. You can even model this problem without a distribution. It's not a be-all, end-all. And there are multiple ways to solve distribution problems, but this is just the way that uses the distributive property most explicitly. So it's the way that I'm going to show you in this video, but there are other ways that you can discuss with your teacher about doing yourself if you prefer those other methods. The key is making sure it is following your order of operations, following your properties of equality. If you follow those rules, you will be correct no matter if you do it exactly how I'm showing you or if you do it in a different way. But the key is having a logical path and following it. So I'm going to distribute that 25. It's going to multiply the 3x and the 1,000. 25 times 3x is 75x. 25 times 1,000 is 25,000. And I still need to add the 3,575. Still going to be less than or equal to 31,575. Now I've got like terms that I can combine, the positive 25,000, the positive 3,575, they're both positive. So these guys are going to add to each other. So now I have 75x plus 25,000 plus 3,575 is 28,575. Less than or equal to 31,575. We now have a two-step inequality, so we're now getting into the place where we know, okay, let's just follow those reverse order of operations. We are going to deal with additions or subtractions first. I see an addition. I'm going to subtract that 28,575 from both sides of my inequality. They will cancel out. 75x now gets to come down to the next level, and this gives me 31,575 minus 28,575 is 3,000. Last step, 75x is 75 times x, so now I'm going to divide both sides by 75, and 3,000 divided by 75 is 40, so the cost per plate needs to be less than or equal to $40 in order for our nonprofit to meet its budget requirements. And then finally, we are going to graph our inequality. Remember, when possible, do it the way that is simplest for you. We know that our target number is 40. Less than or equal to is a closed circle. Less than goes into the direction of the left to indicate numbers smaller than 40. And then we are good. We have written an inequality, solved it, and graphed it based on this problem situation and used it to find the solution to that situation.